Okay, so today we come back in this module to discuss dislocations in yet another type of system, which is hexagonal systems. Okay, so in hexagonal, as we will see, we can also have a hexagonal close packed system or the hexagonal regular system. So let us start with now when we say hexagonal, you all realize that hexagonal is not really a unit cell, the unit cell is rhombus type. So how does the hexagonal system look like? This looks like so there are atoms in here and there is also atom over here in the center. Similarly, there are atoms over here and there is atom in the center. There is also another layer over here where you can say the center of this line, another center of this line, another center of this line. So, if you combine these, there will be another atom here, another atom here, another atom here. They are all, if we are talking about a metallic single phase system, they are all same atom. I am just drawing in different colors because it is easier to see over here. So, these are the different atoms that you see. Now, here the real symmetry, if you look at it, would be or the unit cell, the real unit cell would be like this. So, in here this is how so this is the unit cell that would be actually there, and here you will have so this will be A1, this will be A2, this will be C. But then there are a lot of things that this kind of unit cell misses. First and foremost, the symmetry of, so if we what we are calling as, actually I should call it B. So, this is A which is termed as A1 and B which is termed as A2. So, what this misses is the symmetry of A, B and minus A minus B. So, this is not captured in here. Not only that, when we write the indices using this system, then the symmetry and other properties are not easy to, other you can say crystallography is not easy to visualize. Okay, so, we come back to this system, and over here we do not use the usual Miller indices. What we use is called the Miller-Bravais indices. So, we will introduce so in this particular system what we do is that we have three different, so in the plane itself we have A1, A2 and A3. So, in the plane itself we have 3 indices and of course, the fourth one which is C. So, this particular type of system we have what you can say U, V, I, and so this is the system where whether you are talking about plane or the direction, you have U, V, W is in the usual system, but here we have a third one I, and this I is not independent. This is dependent on U and V, as we will see in just a moment. So, here the way we describe, we said that there are 3 lattice indices A1, A2, A3, and if you look at with respect to this, then A1 is equal to A, A2 is equal to B, and A3 is now not an independent, like I said, it is equal to minus A1 minus A2. So, it is a dependent index. This just gives it a more, you can see, easy to visualize where we are really trying to point the index in a hexagonal system. And therefore, any lattice point can be indicated by H A1 plus K A2, or since we had used U V W. So, let me put U A1 V A2 I A3 plus W C. So, this will be the index, the way to index a point in this over here, and as we have already seen that this I would be sum of the other U plus V plus I would be equal to 0. So, that is the way we have defined it. Now, as I was saying that over here we will look at using this system. Now, we have, let us draw just on the plane. So, over here as I defined, this is your A1, so this is A1, this is A2, this is A3. Now, what are the in this new in this new notation, what are the vectors? So, if we are talking about A1, a very easy way to look at it is why not draw it first in the opposite direction. So, let me draw it in the opposite direction. So, this is bar of A1 or minus A1. Now, what is minus A1 equal to? This is equal to A2 plus A3. So, 1 A2 plus 1 A3. So, if I had to find the indices, what I will do is I will write A1, how many multiples of A1, how many multiples of A2, how many multiples of A2, A3, and C. C obviously is 0, we are talking in the plane. A1 and A2 we know they are 1 and 1, and once we have 2 of these three indices, we do not need to do anything else. We simply take the sum of this and take negative. So, minus A1 becomes 1 1 bar 2 0, and therefore, if I had to write A1, I will write 1 bar 1 2 0. But now, one other thing, this is in the sense of direction it is right, but magnitude wise if you look at it, this we are going A1 A2 over here, A3 over here. So, we are A2 1 A3 1, and therefore, A1 was minus 2. So, A2 1 A3 1, and we are going minus 2 in this direction. already minus a1 and we are now adding 2 more. So, this is minus a1, this is minus a1, this is minus a1. So, this is 3 times of that. This therefore, I will have to multiply it by a factor 1 by 3 and this and take the negative of this, because I, to make it simple, I have taken a negative direction. Now, using the same principle, I can get a2 equal to 1 by 3 . Similarly, a3 . So, you see I have made this correction, because here I was looking at a1. So, I had drawn it in the negative direction. So, a2 and a3 are 1. So, a2 and a3 are 1 and a1 is the sum of this and negative. So, this becomes minus 2 and this is equal to the minus of a1, because I have drawn it in the negative direction. And like I said, it is minus a1 and then another 2 of the a1 makes it another 2 in this direction, minus 2. So, this is 3 times minus a1 and therefore, if I really want to get the magnitude, I must multiply it by 1 by 3, because this magnitude is actually 3 times of a1 minus a1. Therefore, a1 is equal to 1 by 3. Similar, using the similar methodology, if you look at a2, so this is the a2, this will be 2, others are minus minus, and this is the whole thing is multiplied by 1 by 3. So, that is the way to get a1, a2, a3. Now, we have this, let us look at some of the simple planes and directions for the HCP system. Now, okay, so even before I go, so this was the direction. So, now let me also describe about the plane before we go to the planes. Okay, so, what do we do about the planes? Just like in the cubic system, what you have to do is, if you are talking about any particular plane, now let us say that there is a particular plane which is over here. So, let us say this is the plane that I am talking about, and first you have to describe which are your a1, a2, a3. So, this is my a1, this is my a2, this is my a3 and this is my c direction. So, again what you do here is, what you do is first find out what is the intersection on a1, a2, a3, 2 of these is sufficient again, and then you take the reciprocal of that. So, over here for example, in the a1 direction, this is, so if we have to, so if we have said a1 and a2 are 1, then a3 will become automatically minus 2 and c will become, sorry, here we do not need to do the a3, we will do it once we are taking the reciprocal. So, 1 by a1, 1 by a2, 1 by a3, 1 by c, and c is 2, 1 by 2, it is intersecting at half the length. Now, this will become reciprocal of this is 1 1 1 and then the sum of these two must be, all these 3 must be 0. So, this becomes bar 2 and this is 1 by 2. So, this becomes 2. So, this will be a 1 1 bar 2 2 type of plane. Now, let us look at various possible planes and direction. Okay, here we will also classify what are the different planes and directions. So, the first one, let us say, let us talk about basal. It is one of the most important planes with respect to HCP. Now, this is one of the direction that we are interested in, and what is the plane we are interested in? We are interested in this plane, and our will keep our A1, A2, A3 just like the way we described earlier. So, this is A1, this is A3. Now, since this is parallel to the plane, so obviously A1, A2, A3 are all 0, and the only direction that will lie over here would be in the C, and therefore, it will be equal to 1. Therefore, this is much simpler. We are talking about 1 by A1, 1 by A2, 1 by A3, 1 by C, and since the intersection, there is no intersection in A1, A2, it is equal to infinity. So, 1 by infinity is 0, 0, and this sum of this is 0, this is 1. So, it remains 1, and therefore, the plane is 0, 0, 0, 1. Now, what is this direction? This direction is nothing but the negative of A2, and what was A2? Now, we remember. So, this direction that we are talking about, this is negative of A2, and simply we can write 1 by 3 1 bar 2 1 0. So, this is one of the basal planes. Another basal plane that is possible in this system is, let us draw it over here using a different color. So, this is called a basal pyramidal plane. So, this will be like this. So, here again now we are interested in where is it intersecting on A1, A2, A3 and C. Now, C it is intersecting at half, therefore, 1 by C will become 2. A1 it is intersecting at 1, so it becomes 1 by 1. A2 it is intersecting at infinity, so it will become 0. And since we already have 2 of these, so 1 and 0. So, the third one has to be such that the sum becomes 0. Therefore, this will become 1 0 1 bar 2, and therefore, the plane this that we are talking about is nothing but 1 0 bar 1 2. This is the pink plane. And this is this maroon plane. Okay, so, now let us go to still another plane which is called as prismatic. So, when we are talking about the HCP system, let us also look at what is a prismatic plane. So, this is again another HCP system, and we are talking about prismatic plane. So, where is the prismatic plane over here? There are again 2 different prismatic plane. So, first one let me draw with this blue color. So, this is one of the and just to remind you again, this is A1, this is A2, this is A3, and this is the C direction. This is what is called as first order prismatic plane. What we are interested in are the reciprocals. So, A1 it is intersecting at 1. So, one reciprocal of this is 1. A2 it is parallel to that. So, this becomes infinity, therefore, 1 over infinity is 0. So, now we have 1 0. So, this becomes 1. Now, this one this is again parallel to C, therefore, it is infinity 1 over infinity is 0. Therefore, this plane that we are talking about is 1 0 bar 1 0. Now, let us draw another plane which is called the second order prismatic plane, and it is this one. So, all these prismatic planes are parallel to the C direction. Okay. So, this is now again look at this. So, this is called second order prismatic plane. And now, when we are talking about intersection, so it is intersecting at 1 on A1, 1 on A2. So, the reciprocal of both of these is 1 and 1, and therefore, the A3 which should be the sum negative of sum of these two should becomes like this, and this is parallel to C. So, this remains like this, which means this is 1 1 bar 2 0. Now, at this point one may ask, is this not a possible third prismatic plane? And you should answer why it is not. So, let me tell you, this is not a third order prismatic plane. So, it is for you to find out why this is not a third order prismatic plane, and there may be assignment questions based on this. So, it will be good if you look at it on your own. Now, the third kind of planes and directions which are important with respect to HCP system are the pyramidal planes. So, what are this pyramidal? As the name suggests, it is inclined pyramid like. So, again this is our, and where is the the pyramidal plane. So, okay, let me write the name pyramidal. Again there are more than one type of pyramidal plane, as we will see. So, this is the first one, let me draw. And again A1, A2, A3, and this is C direction. So, what we are interested in again finding the reciprocal of intersection of A1, A2, A3 and C. Now, in the A1 direction it is intersecting at, so this is the A1. So, we can say that it is intersecting A1 and, so this is parallel to A2. So, 1 over infinity is 0. So, this becomes 0, and as far as A1 is concerned, you can say that this is 1, and once you have 1 and 0, the third one becomes bar 1, and the C direction you can see from here to here it is 1 C. So, this becomes 1, therefore, this is 1 0 bar 1 1. Now, another plane that we will draw over here, which is also pyramidal. So, here I missed out telling one thing, that this is 1 over A1 we have taken as 1, because you can consider this plane parallel here. So, this over, if you are taking it here, then the intersection would be at A1 equal to 1. So, that is where we are getting 1. So, you will not take it as 0, that will be not meaningful. Okay. So, here again we have this is intersecting at A1 and A2 at 1. So, this remains 1, A3 of course will become bar 2 and C direction you can see it is intersecting halfway. So, the reciprocal of that will be 2. Therefore, this becomes 1 1 bar 2 2. So, these are the two possible planes when we are talking about pyramidal. Now that we have looked at the different kinds of planes and directions that are possible in the HCP system. Now, let us look at, we are now in a position to look at their dislocation slip system. Now, here again you will see that dislocations can be classified according to some categories. So, the first and foremost thing is direction, meaning the Berger vector, and for each of these Berger vector there will be different possibilities. So, the first thing that we will look at is A, which is along one of the A1 A2 A3. So, we can write it like 1 1 bar 2 0. Actually there would be 1 by 3, but we are right now concerned only on the direction. Now, planes. So, what are the possible planes? The planes are that are possible basal, prismatic, all of these can contain A type of vector and therefore, they are listed here. And corresponding to this we can have slip systems. So, now that you have a direction and the plane, so we can describe the slip system. So, for the basal it means that this is happening only in that particular plane. So, this becomes 0 0 1. For the prismatic and again the direction remains the same. For pyramidal the direction is 1 0 bar 1 1 and the direction remains same, because we are talking only about A type of Berger vector right now. And you can see that there is a continuous certain type of progression, and that would be much more clear when we look at, again what we will need to look at is the different planes that are being described over here. So, what are those planes? First and foremost, this is the direction Berger vector, which is 1 by 3 1 1 bar 2 0. This is one of the planes which is 1 0 bar 1 0. Then there is another plane which is the prisma. So, this was the prismatic plane 1 0 bar 1 0, this is the pyramidal plane which is 1 0 bar 1 1. Then there is a basal pyramidal plane which can be represented like this. One 0 bar 1 2, and of course, this is the basal plane which is 0 0 1. So, these are the different, you can see this is the direction and all these planes, this one, this is basal plane 0 0 0 1, 1 0 bar 1 0, 1 0 bar 1 1, 1 0 bar 1 2 and 0 0 1, they all contain this particular direction and this all can lead to a type of dislocation slip system. So, let me just finish with the last type which is possible, which is C plus A. And there is only one type of plane, pyramidal, but then there are three types of pyramidal possibilities, as we will see. So, the slip systems so, bar 1 2 3 is the C plus A type of slip system, and as we will see this is the where is this C plus A. So, this is the A direction, this is the C direction. So, C plus A direction is nothing but this one, and this is 1 by 3 bar 1 2 3, and where are the planes, we will see the planes right now. So, this is the first plane that we talk about is this one, this is one of the pyramidal planes, the other one is this one, and the third one is this one. So, this one is 1 1 bar 2 2, this is 2 bar 1 bar 1 bar 1, and this already we have already derived earlier. So, I am not going into it again, this is 1 0 bar 1 1. So, these are the three different systems, and we will come back and discuss more about this slip systems a little bit more, and then we will talk more about the dislocations in HCP and the possible stacking faults in the HCP system. So, we will end our lecture with this. Thank you.